students, welcome back to my channel once again. So again, one more project related to a very current situation, that is flood and landslide, which happens in the rainy seasons. So flood and landslide early warning system using Raspberry Pi Pico W with MicroPython. So here, first we will see the project overview. Natural disasters such as flood and landslide causes significant damage to lives and infrastructure. This project develops a low-cost IoT-based. Please remember, it's IoT-based because we have used Pico W board, okay, embedded system board. So base flood and landslide early warning system using the Raspberry Pi Pico and W. Okay, Pico W it is. The system will, what it will do, the system will monitor water level, that is for flood detection, soil moisture for landslide prediction, ground tilt and vibration. We have used here MPU 6050, a new sensor 6050. Sends data to ThingSpeak cloud. The same data is sent to ThingSpeak cloud, and there it is. We can just check, or anybody else can go and check what is the situation. Generates a warning alert, an active buzzer and warning LED will be there. That is for the local. Okay. So the system is suitable for where we can use this system: villages, riverbank, hill area, schools, disaster monitoring labs, engineering, mines, major projects. There this can be used. Okay. So components used in this, as you can see in the picture also, one Raspberry Pi Pico W1, that is because it's an IoT project, so we have used a Pico W for that. MPU 6050, that is gyroscope plus accelerometer. It is soil moisture sensor, the normal soil moisture sensor you can use. Ultrasonic sensor, of course, you can use SR04 or submersible other ultrasonic sensor if you want to check the real depth of the your rivers or ponds. Then I have used an active buzzer, that is buzzer for sound, LED for with the 220 ohm resistor for indication, breadboard, jumper wire, and USB cable for programming. Then the connection wise, as you can see, soil moisture sensor is connected. Sensor is connected to 3.3 volts ground, and it is connected to A0 GP26 of this thing. Or you can change this to GP26 or 27 also. Both of them are AO, that is analog pins. Whereas MPU 6050 is connected to the SD is connected to GPI 0, SCL is connected to GPI 1. HC05, that is ultrasonic sensor, is connected to GP02, and that is the trigger pin, and echo pin, that is through voltage divider, it is connected to GP3. Now, please remember here important before connecting your HCSR04, that is because it works on 5 volts. So please remember that is the Pico works only on 3.3. So the HC04 echo pin output 5 volt, while the Raspberry Pi Pico W is 3.3 volts. Torrent. Use a voltage divider. This is important to use a voltage divider. For example, 1 kilo ohm and 2 kilo ohm resistor for a logic level shift on the echo line. Okay, only for the echo part. This is the echo line, that is GP3. There you have to use this. LED is connected to 15, buzzer is connected to 60. So these are our connections. Okay. Important project features, what you have to write or what you have to say about that. That is non-contact flood monitoring using an ultrasonic sensor. Right? You can use ultrasonic sensor, non-contact, that is for flood monitoring. Soil saturation monitoring with a soil moisture sensor. That is soil moisturizer. It will tell you whether the ground is moving or there will be a landslide. So that is the purpose of this. Ground tilt and vibration detection uses this sensor, that is MPU 6050, is used for ground tilt and vibration detection. Real-time data upload to the ThingSpeak cloud. Okay. We will see, and we'll go to the cloud and we'll see LED and buzzer for local alert. Wi-Fi connectivity through Raspberry Pi Pico W, low cost and suitable for continuous outdoor monitoring. So example on the right hand side, what it will be shown, that is water distance, that is done by the ultrasonic sensor, it will be in centimeters. Soil moisture, it will be in the percentage. And tilt X and Y, that is the MPU 6050 output. Okay. And finally, it will come whether it is safe or it is dangerous level or whether it is alarming level. This ultrasonic base design is more reliable for the riverbank, again, bridges, dams, canals, drainage system, because the sensor does not come into direct contact with the water. You have to keep it above the water, right? So reducing the maintenance and improving long-term performance. That is important for this thing. That is the improvement project features. Now, this is the simple schematic diagram I have made on Walkthrough software. So soil moisture sensor, you can see here plus and minus and which pin it has been given. 4 connection SCL STA from 6050. This is my LED buzzer and my ultrasonic sensor with a divider. That is 2 resistor I have just connected. I said the eco pin has to be connected and given to the web. So these are the schematic diagram for that. So let's go to the lab and check it on screen. This is, I have made it on a breadboard. There is an alert system going on. Why? Because the water distance, I've kept it little near to my ultrasonic sensor. So this is my Pico board. It is I have just connected it to the computer, the power supply. This is my soil moisturizer sensor. Behind this, you have buzzer and LED also. Right now, the LED is glowing. And here in the corner, I have kept the sensor, that is still sensor, that is 6050, MPU 6050 sensor. Okay, so when you move this board, that is when the earth moves, actually, it will indicate here that I will show you on the screen, how it comes onto the screen. Now, suppose this, now the light has gone, as you have seen, the light has gone. What I will do is, I will just show you by opening the ID. So I will just go to the ID first. As you can see, Thorny ID. This is the Thorny ID for micropython codes. So these 4, 5 are the libraries at the beginning. But especially you have to take care of the NPU 6050. This library, the Utine network and other libraries will be there built in already inside. I've taken the SSID and password. Then ThingSpeak key will be there, right? The right key will be there. That you have to copy it here. Then trigger pin, how the connection has been made. So this pin number 26, it is the one ADC, that is right. Analog pin 26, 15, 16 is for LED and buzzer. In trigger and echo, accordingly 2 and 3, it is connected. Okay. So this is about the NPU 6050 because it is ID2 also I2C. So this connections here is given, and rest of the things we have to send it to the ThingSpeak ID, which I'm going this course, which I'm going to share with you. Also, is a MicroPython using Raspberry Pi Pico W. It is an IoT. One more important thing is here you can change the distance, that is less than 20 flood, and less than 50 it is warning or something like that. So this parameters you can change it. You can change according to your requirement. That is, it is here are given more than 1.5 and more than 0.5. That is the landslide parameters. So these parameters X and Y and other parameters you can just change according to your requirement. Okay, right. So I will just stop it here. You will find this thing. I will just run this program, main program. Now the program you can see here on your shell monitor. It has started. I will just try to increase the shell monitor. This is my shell monitor. So you will see how the changes are taking place. It is connected. That means all this information is going to the ThingSpeak clock. Okay. So every time it will be changing. As you can see, soil moisture is 0.9 and 23.80 is the distance of the water, and it's showing warning. That means it has come nearby. If suppose flood warning will be there, then as I said, the light will come over there. Okay. So this is about the code part. Then I will show you the ThingSpeak, this thing, how does it look? Okay. All right, so this is my ThingSpeak dashboard. So 3 fields are made it here. One is water distance for flooding. Okay. Second is soil moisture in percentage. That will tell you what are the chances of this thing, and the landslide. Okay. Landslide is this parameter is nothing but about the sensor 6050. It will be changing according to your data, which will be, if it is moving or whatever it is happening, it will be changing according to that. So I will just try to move it around here and let's see what happens exactly there. So you see here it is coming. Then I will stop share this. I'll go to share, and I will go to this place. Okay? That is my this thing, and it will change automatically. Okay, it will be changing, and you must have seen it will be changing all the 3 parameters. You can keep 4 parameters also. So date and everything, time, date, everything will be coming over here. And what if the changes are there, you can directly see what is the time it has come, the last update was come. It will be telling you here. So this is about the distance and about the project. I hope you will understand this project. If any questions are there, simple. Please remember, whatever I do, I show you these all as a live projects, okay? Which will be helping you, and you can add or make some changes to this. And you can, this is simple an idea for you people or you or people, so that you can get some new information. So already we have discussed about this in previous videos, how to make this channels and how to do this. Okay, I hope you like this project, and please subscribe to my channel if you want to learn more. Please do write to me in the comments. Thanks for watching. See you next time.